All right, well, welcome everybody. I know some people are still filing in, coming back from lunch, but I want to thank you all for being here. And if you don't mind, it's kind of an awkward room, it's a bit wide, and we have a big pole over here, so I'll be moving around, and I want to keep myself off the stage because I have less chance of falling off it if I stay off it. So just to start, my name is Mike. And I have to make a confession to you all. Even though I don't really know many of, I probably know a few of you. But I am not a data scientist. So how many people in this room are data scientists? Let me get a show of hands. Okay, Amanda, they're not allowed to ask any questions? Okay? No, I love data scientists. And I wish I could be one. But I took a bunch of stats classes in college and graduate school, and I found them a tad challenging. When I work with data scientists, I'm impressed about how much they know. I'm impressed about how curious they are about data, and I wish I could do it. And what also makes me wish I could do it is, this article that was written in Harvard Business Review, an esteemed publication. They called data scientists the sexiest job of the 21st century. So who wouldn't want to do that? Right? And I've been in analytics or analytics solutions for 25 years. And back when I was doing this, we called it data warehousing, which, I don't know, warehouses? I've worked in a warehouse. They're not very sexy. So look, what's good is we've gotten better at marketing what we do, which is a plus. Speaking of marketing what we do, being a data scientist has become so cool that Dataiku, we helped produce a documentary on data scientists, where we spent time with 22 different data scientists from different organizations, and just finding out how they think, what they do, what challenges they face, where they see the industry going. And so I recommend going to our website and checking this out, because it's pretty interesting. And data scientists aren't only sexy, but they're cool, because in this documentary, you see data scientists doing things like typing on a laptop and writing on a whiteboard and walking, but it's all in slow motion. And in any movie you see, when people walk in slow motion, it looks really cool. So we did that in the documentary, so it just adds to the aura of the data scientist. So, like I said, I'm not a data scientist, but I am a data analyst. And since this is a Tableau conference, and one of the things we do at Tableau conferences is people talk about how many TCs they've attended. And I've attended quite a few. And I also have some street cred, because I'm willing to bet that I've been using Tableau longer than 90% of you. So real quick, show of hands. Who's been using Dataiku? Who's been using Tableau since 2017? Show of hands. Okay, that's what I figured. Keep your hands up. 2015. 2012. 2009. 2008. Nice. 2006. Yes. 2005. So in 2005, I worked at a company called Hyperion. May it rest in peace. It's now part of Oracle. But Hyperion, we sold a multidimensional database, and we OEM Tableau to do visualization on top of our multidimensional database. And generally, our users were finance people. And so at first, we're thinking, do finance people really want to, these are numbers people, do they really want to work with Viz? Well, they did. And it made our application much more approachable and much more usable for a wider set of audiences. And really, that's what we're trying to do with Dataiku and with the integration that we've built with Tableau. Is, heretofore, data science has been for data scientists. And our reason for being as Dataiku is to expand that user population and really democratize data scientists, to get more people involved in that analytic conversation. So it's not just for data scientists, that analysts like ourselves can work with our friends, the data scientists, to do data science and do it at scale and do it better. So that's what we're going to talk about today. And so to give a little context, I want to talk about the state of enterprise AI. Now I use the acronym AI, and for this talk, AI and data science will be relatively the same thing. I know it's a whole different discussion that I don't want to get into today, but for this talk, data science, AI is the same thing. I want to talk a little bit about the value that Dataiku brings, the value that we bring together with Tableau, and then we'll show you a little bit of it. And then we're going to have a discussion where Chris Kakanat from Pfizer is going to join me up here, and we're going to have a discussion around, he's on the front lines of doing this work with Dataiku and Tableau, and we'll have a discussion around that and how he's doing it. And I'm hoping you can learn a lot from that. So real quick, in terms of the state of AI in 2017, there's a quote from 2013 that I think is so relevant to what we're talking about. I included it here. And it's from a gentleman by the name of Dan Ariely. And Dan does a lot of TED Talks. And he was talking about big data at the time, but he said, big data is like teenage sex. Everyone talks about it, but nobody really knows how to do it. But everyone thinks everyone else is doing it, so everyone claims they're doing it. And that was the state of big data in 2013, and I'd like to argue that that was the state of AI in 2017. Everyone was talking about it. And we have research, this is funny, but we have research to back this up. So an organization called CB Insights did a survey, or actually they observed CEO earnings calls over time and marked the number of times that the words big data or AI were used. And you see big data was a thing starting in 2012, and that peaked. But then in 2016, the use of AI skyrocketed. And now this wasn't tech companies talking about AI. These were companies that sell shampoo, cereal, and they went out and told the world that they're using AI to transform their businesses and get people to buy more shampoo, make sure that shampoo that you buy matches your head. I don't buy much shampoo. But using it to transform their business. And what they probably did when they get off these earnings calls is they went back to their organization and said, all right, I just told the world that we're using AI to transform our business. Now let's go do it. And there was a chief analytics officer or someone of similar title who looked like this. Oh my God, what are we going to do? So how do we do that? Now, fast forward 2 years, and I think we've gotten some value out of AI. So McKinsey did a study, and they studied 2,000 use cases across 40 industries, analytics use cases, and looked at each of those and looked at the share of use cases that had AI involved. Now, 15% of those use cases didn't need AI. So descriptive analytics is totally fine, and you can get a lot of value out of that. 85%, there was value in using AI, whether AI added helps or it actually was required. Now, okay, so what was the result of those use cases? Well, they analyzed the ones that were using AI, and they found that organizations were getting a lot of value out of deploying these analytic solutions using AI. Even in industries where the use of data is highly regulated, like healthcare and public sector, still getting great returns on that, over 40%. And then in industries where people are more free about giving their data for travel, they want to get an upgrade, or for retail, they want to get a discount, even bigger value. So there's value in doing AI. So we've gone from everyone's talking about it, but no one really knows how to do it, to, all right, we're getting a lot of value out of it. So how do we do it? And that's where, so in terms of how do we do it, the challenge is not software. There's a lot of software out there for any of us to do AI. There's all kinds of open source out there, and there's almost too much out there. So the challenge is, still, there's a data challenge, right? Because data is still siloed. There's too much data. It's in different formats. It's structured. It's unstructured. It's in the cloud. It's on-prem. It's in people's files. It's on their laptops. There's a lot of data around. But the other challenge is that our people are siloed as well. So it's really difficult for somebody to understand the business problem, understand the data infrastructure that they need to put in place to make it happen, and then have the analytic acumen to make it happen. So that person is a unicorn. And if you are one of those people, come see me afterwards, because I'd like to talk to you about a job. But it's something that organizations are struggling with, because having that one individual do that is hard to find. Then the last is those siloed processes. So there is different processes of a small data team that can work with servers under their desk, and they can iterate in sandboxes very quickly, versus a large IT organization that has a lot of hardened infrastructure where pushing something to production is a major task because of governance, because of security. So these are things that are challenges in making this happen. Now, I'm not saying we solve the data problem, but we have access to enough data to do good data science today. So this is there. In terms of the people and the processes, these are a bit more challenging, but this is the challenges that Dataiku seeks to solve. And so a little bit about Dataiku. We were founded in 2014, founded by 4 data scientists, and I think they felt like they were overworked, so they wanted to get more people involved in the data science work. So they developed a product that allowed people to do the data prep and the ML, machine learning, in one platform. And we started selling this platform, making it accessible to larger organizations, and they started wanting to do more and more in terms of getting more people involved, so we added collaboration features, more in terms of getting more data involved, in terms of getting it to work within the confines of their infrastructure, so we added capabilities of working in the cloud, et cetera. And through that, we're able to grow with our customers. So we now have over 300 customers, and we have some customers that have over 1,000 users. So 1,000 users doing data science. And that's pretty cool. And that's part of the goal of when we talk about democratizing data science is getting all those people involved and getting these different profiles working together. So far, so good. Now, what are we doing for these organizations? Now, this is not a verticalized solution. So we partner with our clients and also with our consulting partners to deliver verticalized solutions. We're a platform to make that happen. Now, as is often the case, marketing leads the way with a lot of use of analytics because the ROI is easy to prove. And so you see a lot of marketing use cases like cross-sell, upsell, next best offer, recommendation engines, segmentation, things like that. But we're also seeing it used in finance in terms of understanding risk, using it in operations in terms of doing predictive maintenance, and then also in other areas such as logistics optimization or supply chain optimization. You see some of the different logos on the left or your right. A lot of different industries. One thing these organizations all have in common is that they want to do data science at scale. Because if I'm building 10 models, I don't need a platform to do that. I don't need a platform to manage that. But if I'm doing 100 or 1,000, I need a platform to manage that because that can become unmanageable very quickly, and unmanageable AI or data science is a very scary thing and can be very dangerous for an organization's reputation and for how they use data and what people find out about how they're using data, as we've seen. So how do we do this? So generally, when we're doing data science, there's 3 profiles of people involved. Our data scientist friends, for those of you here, our analyst friends, and I didn't ask, are there any data engineers here? This isn't really a data engineering conference, but they're our friends too, because when we build something as analysts and as data scientists, we need to work with the data engineers to actually operationalize that and put that into production. Now the challenge is that we all speak different languages. We work in different tools. So I'm an analyst. I like to work in a GUI. I like to work in a drag and drop environment. I'm very comfortable working in Excel. Maybe I'll code a macro or 2. So I work in those types of environments or using data preparation tools. And if I'm going to do ML, I'm going to do it using some sort of visual ML tool because I'm an analyst. I don't code. Now, if I'm a data scientist, I code. I code in R or I code in Python, and I generally do that in a Jupyter notebook. And so I'm working in a different environment than our analysts. Now, our data engineers work in API platforms for deploying these models. And the problem is all these people are working in different paradigms, different languages, and communicating becomes very difficult. And when communicating becomes very difficult, it's very difficult to do anything efficiently. So what Dataiku does is we provide them a single environment where they can work together. Now, we're going to still allow them to work how they want to work. So I'm not going to take a data scientist and say, you can't code anymore, use this GUI, because they won't. Then they'll quit, and that's bad. And I'm not going to take an analyst and say, here, start coding, because they don't have those skills yet. Now, there's a lot of analysts who aspire to be data scientists, And by having them collaborate with data scientists in the same environment, now they can upskill themselves and one day become a data scientist, which isn't a bad thing because it's the sexiest job in the world. So how does this work in an example? So the steps to doing data science is a cool term, but it's actually, in terms of how we spread out the work that's being done, it's pretty simple. Is I need to access data. I need to do something to that data to make it ready for analysis. Once I've shaped that data and it's ready for analysis, I can apply some machine learning to it. And I keep iterating and keep testing. And once I'm happy with what I have, then I deploy it. Sounds simple. Now, if I can get different people involved in this at different stages, using the tools that they're working in, I can do this very efficiently. And so sometimes my data scientist will be the one doing the machine learning. Sometimes my analyst will be doing it via the visual ML. Sometimes my data scientist will use code to do the data prep. But oftentimes that's work that we can have our analysts do, because analysts are comfortable doing that. And then as an analytics leader, if I have all these different personas working in one environment, now I can manage the work, and I can deploy them in the way that they're most effective. So there's a lot of benefits for different people within this structure. And then once that model is built and tested, my data engineer can also work in this environment to deploy it and then monitor it in production to make sure it's still functioning well. So we're all getting along. Now, we need to do it in an infrastructure that works for doing it at scale. And so in terms of the users, this has to be browser-based. We don't want people dragging down billions of rows to their laptops because my laptop will explode. There's also a governance issue there. So they're going to be working in a browser, working in a server. Now, our servers can live on-prem or in the cloud, depending on how you want to structure your infrastructure, or hybrid. And we have separate servers for doing our design and development, and other servers for doing the batch deployments or for deploying it as a callable API. So there's flexibility until I can, in terms of how I can operationalize these models, and then push that information in creating the data products that I need to do my work. Many times those data products will be a scored data set that I can then visualize in Tableau, or a scored data set that I insert into Salesforce so that when my inside sales team comes in the morning, I have the top list of accounts that they need to call. So you can think of Dataiku as an orchestration layer for everything that's going on underneath in terms of execution engines, so I can leverage the best technologies out there, the latest technologies, but also the layer that my different personas can interface with in the way that they're most comfortable. So let me show you this in action. Now, there's a lot of technology going on here, so I'm going to run you a video, and this is a video that our product team made after they had about 15 Red Bulls. So this video goes very fast. So I'm going to pause it throughout the way, and God willing, it'll make sense. So let's start it. Okay. So like any other system, you log into it, and first thing you see is a list of projects. So these are projects that I have access to. They're personalized for me based on my access rights. And let's dig into a project here. So I can click into a project, and this takes me to a project's homepage. Oh, told you it went fast. All right, so this takes me to a project's homepage, and there's a lot going on this homepage. And this is where, once again, I don't need to be a data scientist to understand what's going on in this model, because it's documented here for me. So my analyst or my data scientist, whoever's working on this model, documented exactly what the purpose of this model is down here. They can assign tasks to different people in this model here. And everything any action that's taken place in this model is documented in our internal Git here. So as an analytics leader, I can see who's done what on this model. And if someone's done something that we don't want them to do, I can roll it back via the same interface. Now, I also have some metrics up here in terms of when this model was last worked on. And I can also see some high-level information on what's going on in this model. So in this case, they're accessing 32 different data sets. They have 29 different recipes that are acting on this data. So a recipe is an action on a data, like data preparation, like joining data, for example. And then there's a bunch of different analyses here that are going on in the lab. Some of it has been done in a notebook by a data scientist coding. Some of it has been done in visual ML using our visual machine learning features. And then also there's this automation area here. So what that tells me is that this product has been deployed via our automation node in production as a batch process, and I can see when it's run and if that run was successful or not. So there's a lot of good information here just on the homepage of the project. And if I click on that flow button, it takes me to the flow. Now, anybody who's worked with other data prep tools, this will look pretty familiar. It's a visual rendering of the project with these blue boxes are connections to data. These yellow circles are visual recipes acting on that data. These orange circles are code recipes acting on that data. And then these green icons over here are machine learning models that have been applied to the data once it's been prepared. And so digging in a little bit to our, in terms of data sources that we can work with, connect to all different types of data sources, structured, unstructured, SQL, NoSQL, Hadoop, cloud storage. And if there's an instance or a type of data connection that's not here, we have the ability for data engineers, data scientists to build plugins to connect to whatever kind of esoteric data set you have. So we can get the data into the model so you can do your analysis. Now, once I'm working with the data in let's say a prepare recipe, I can profile that data. And so in this case, I brought some data in. I'm looking here at a column, and the system's automatically profiled the data in that column for me, so I can see the distribution of that data. I can get some stats on that data. And it's even recommended a couple actions for me based on the type of data that's in there. So that's some of the automated features that are here in terms of the data preparation. And then you see these steps here on the left. These are the common steps that we do in terms of data prep, parsing data, changing strings to dates and vice versa and things like that. And we have 90 processors, so I can do that without having to do any code. So all very simple for the analyst to do. Now, so once the analyst has done that, now once I've done some action on this data, I can profile the data via visualization in the flow. So this isn't something meant to replace Tableau. This is visualization done in the flow to make the design process easier and more efficient. And then I can also get stats on when each of these objects have been worked on and who's worked on it. So as an analytics leader, I can see who's doing this work. Now, once my data is accessed and prepared, I want to apply some machine learning to it. I can do that, as I mentioned, via code or via visual. And here I can do it via code, and here I can jump right into my Jupyter notebook. It's built into the platform, and my data scientists can do their work in the notebook. We also have the visual ML feature, so I can work with different ML libraries, and as I can select different algorithms, run those algorithms against the data, and see which one performs best. Now, as an analyst, it helps if I understand what each of those algorithms is doing, and we explain some of the details of what those algorithms do, so we're not just blindly applying ML and trying to deploy something. So there's some descriptions behind this to make it more understandable. And then if I'm a data scientist, we also have what we call expert mode, where I can work with advanced features like TensorFlow or Keras and doing deep learning, all still within the same platform. Now, the other thing I have as a data scientist, or even as an analyst, is I can control where the processing takes place. So what we're showing here is a join. And if I want to do that join back in the data where the data lives, so I'm not moving the data, I can do that, and I can decide where that executes depending on what kind of data set I'm connecting to, or I can do it on the Dataiku server. And as a data scientist, I can see the code behind this and tweak it if I want to. So lastly, once I have built and tested a model, I want to deploy it, we can build scenarios to deploy that model. And so I can define a list of steps that I want to take place every time we want to run this model in production. And I can even do some reporters on this so that I can be notified when that model ran, was it successful or not, and what was the result. And that way I understand what's happening in production and can be notified on a push basis versus me having to check. So that was a very whirlwind tour of our platform. Now I want to get a little bit into what we do with Tableau. So you've seen some of the features that Dataiku does in terms of the data access, data preparation, and the application of machine learning. Now we want to get that information out to a broader audience. And what platform does that broader audience generally use in analytics? It's Tableau. And so we can do a lot of that work within Dataiku, which is not just descriptive analytics, but also predictive analytics, and get it out to that user population. And we can, once again, doing it within a governed, secure environment that everyone is working in, and as an analytics leader, I understand who's doing what within that environment. Now, I'm going to show you one more video, and these videos aren't as interesting because a lot of the magic's happening behind the scenes, but what basically is happening here is we're building a model in Dataiku and applying some machine learning to it, pushing that prediction out, and now we can push that prediction out to Tableau, and in this case, a Tableau server, as a simple export. And so now I can do my data science within Dataiku, get a prediction here in this last column here, and then export that to a table that is then picked up by Tableau server. And now I'm talking too fast for the video. It's switched. And then once that data is in Tableau server, now I can go into Tableau, pick up that data, and then build my viz, now not just with the raw data, but with the prediction that came out of Dataiku. So that's pretty interesting in terms of being able to do that work in Dataiku and then push it to Tableau. Now, we also have integration that is the other way, where I can be working in Tableau and I can call the Dataiku API, so basically call a predictive model. So this leverages TabPy integration. So let me pause this. So this is a Tableau viz that shows the prices of Airbnbs in Paris based on certain parameters. Now, what I can do within this viz is I can change those parameters in terms of the number of people that the apartment or the condo can accommodate, the number of bedrooms, and other factors, the ratings, et cetera. And as I'm changing those parameters, my visualization is changing and my prediction is changing. And so what it's doing is it's sending those parameters back to the Dataiku API, running that model, and sending back the result. And then you see that change right here. And the last integration I'd like to show, and so here's the code that's happening behind the scenes. And it's very simple, is we're grabbing those parameters and passing it to our API, and we're returning the result. And the last integration is somewhat related to this, but now we're going to be working with Tableau Extension, where I can work within a Tableau viz, work with a data set, select the different columns of the data set that I want to build a model with, and then build that model. Play this again. And then build that model on the fly. And so here, I have a data set here that I'm working with. I'm going to select the different variables that I want to include in this model. And I'm going to select the column that I want to predict. Click a button. It's automatically running the batch process within Dataiku. And now Dataiku is rendering the results within Tableau, showing, let me pause this, showing which variables were most important to that model. So that is a whirlwind tour of our integration with Tableau. And this is a summary of the different benefits that the different profiles get from this. So now my analysts are doing predictive work, but doing it in the platform, Tableau, that they're comfortable in working in. My data scientists are able to get a way for their work, the good work that they're doing, and get it out to a broader population of Tableau users. And my data team leaders now it makes it easier for our team leaders to manage all this infrastructure, because now I have less moving parts in terms of I have Dataiku managing my data science piece, I have Tableau managing my enterprise viz. Now that makes it easier for me to manage my overall analytics environment. So we do have some great organizations that are doing this today. And I'm going to have Chris join me in a moment, and we're going to talk a little bit more about how he's doing it at Pfizer. But I just want to close this session with going back to this article about the data scientist being the sexiest job. And this was written in 2012, and it's very prescient in terms of, if you look how this article ended up, where they talked about data scientists' most basic universal skill is the ability to write code. Still the case today. But this may be less true in 5 years' time. So it is a little bit because of tools like ours that are making data science more approachable for the analyst. When many more people will have titled data scientist on their business card. That is totally true. There are a lot of people who have data scientists on their business card because if you have that on your LinkedIn and your business card, you probably get a raise. But more enduring will be the need for data scientists to communicate in a language that all their stakeholders understand, and to demonstrate the special skills involved in storytelling with data, whether verbally or visually, or ideally both. Now, what platform does storytelling with data visually? Tableau. And so with the integration of Dataiku and Tableau together, we're bringing data science to Tableau and can democratize it and bring it to more people. So with that, I would like to invite Chris Coconut from Pfizer to join me up here. Hi, Chris.
Good to see you.
Good to see you. Yep. For a little fireside chat without the fire. How's it going, Chris?
Pretty good. Can you guys hear me?
Yeah. And sorry for you people out there, you can't see us, but the stage is too small. We'll be down here. So Chris, what do you do at Pfizer?
So I lead a data science innovation team within centralized analytics organization. And we cover globally all markets, all products, business units. You can think of it almost as an internal consulting organization for analytics. And it's organized in a way where we have, I would say, sort of liaisons with the business units. They sit in with the actual business units, as well as centers of excellences. And I lead one of those centers of excellences. It is called Data Science Innovation. And we work on a wide variety of projects. I think we're split into two main capabilities. One is, how do we actually scout and develop an innovation lab capability where we're bringing in new innovative capabilities across the continuum. So this could be from data engineering, machine learning stats, interactive visualization, storytelling, really out there trying to understand what is the best and latest and greatest innovations. The second part is, how do we actually activate that? So this is developing projects and applying data science at scale, really on some of the most transformative projects within the company. So this ranges from R&D all the way to internal operations. So things like HR analytics or looking at meeting effectiveness, as well as detecting early diagnosis of rare diseases. All of these types of projects is what we try to innovate on and almost show it as a lighthouse of a project, and then the rest of the organization can see what's the art of possible.
So when did you start this?
This is my 10th conference for Tableau. So I started using Tableau probably in 2008, 2009. So the actual journey of developing the platform probably started about 5 years ago. But we've been on this sort of crusade about data democratization for about 10, 12 years now at Pfizer.
And where would you say you are in that journey?
It's, as you mentioned, I think, software technology is not the only answer. There's a lot of great tools out there. It's really about changing the culture, making people data literate. How do you actually get folks from all parts of the business to be involved in the data science or analytic process? And so, tools help a great deal. I think we've made strides in sort of the data accessibility, like being able to catalog and share and find data very easily. I think the part where we're trying to figure out is the reusability of what we call an internal marketplace of either analytical solutions, data products, things like that. So we've gone on a level where we're starting to publish these things internally, but the next level is, how do you do that at scale? How do you have an internal structure to maintain these products? Who's responsible for that? If the data science team builds a model, encapsulates it in a recipe or a actual internal app. We have like an app concept. What's the actual maintenance of that? And so that's what we're trying to figure out. This is what folks call maybe DevOps or ML ops. How do you actually maintain these models in production?
So does that allow for people to, let's say I find one of those models that is built, and I sit in a different organization. Can I just go and use it?
Yeah, so there's obviously privacy and sort of security behind it, but the idea is that everything is transparent, and so having the ability to trace back the lineage of a certain application. I think you saw today with Tableau showing the lineage of certain data applications, but really the power here is that you have data engineers, business analysts, machine learning engineers, all in the same environment. So no matter what your skill level is, if I don't know anything about data engineering or I don't know how to write Spark code, if I wanted to learn, I can actually see how that was done. So I have the actual output of a project, and then I can actually go in and figure out, okay, well, that's how you write that, I can do that. And then reverse part of that is, as a data scientist, we can go back into the flow and understand where are these, maybe we see some anomalies in our model. Like the model is saying a certain variable is very predictive. Well, why is that happening? Well, maybe the person who pulled the data extract didn't apply a certain rule. So instead of making an assumption about the model, we can go back in and understand where the data's from. So that's a big piece of is transparency. This is really big in sort of the ethical AI implications, understanding where exactly the data, what transformations are there.
Now, so this was, you changed the way people work, and change is hard on people. So did you get pushback from anyone or everyone? And which groups pushed back the hardest?
Yeah, it's actually very, nobody wants to sort of, people are very protective over their specialty and expertise. And analytics has traditionally been, the oracle in the back, saying that this is the best model or this is the prediction. Really opening that up is hard on all sides. So from statisticians, machine learning, data, everyone is protective of their own space. And at the end of the day, we're just trying to make the end business impact. So really trying to get everyone to understand it's not about, security and access and like who knows the knowledge. It's really about sharing that across the organization.
So how do you, so it sounds like you've done pretty well with this, but how do you measure success?
Yeah, there's different ways. So we have, almost 600 to 700 users using these applications. We look at sort of globally, these are users all over the globe. And you can look at different metrics of sort of impact. One is usage, right? That's the most basic metric. You can basically look at how many people are using it, how often, what's the actual reach of our capabilities, the types of users that we have. So the variety of projects is very important, not just one use case. And I think the way we're measuring it is across our organization. If we look at the executive C-suite, if each of those, if the CFO, the CEO, CTO, all the different Cs, right? If they're actually leveraging analytics in together across a round table, if the organization actually acts like that, that's how we're sort of measuring that progress. And so, the really nice things, we're breaking down barriers and really bringing in teams from medical to statisticians to biostats, biologists, working with data scientists. It's really an exciting time when you start getting people out of their sort of tool sets and more about solving a situation. I think earlier today you saw the keynote where, I forgot what year it was, like 1940 or 30, it was a team of folks trying to solve a problem, and they're from different backgrounds. And that's what, 60, 70 years later, it's the same thing we're trying to solve for, right? So it's just about people and working together.
So different profiles of people, different backgrounds, different parts of the world. How did you onboard them and get them going? What kind of training did you provide them? And was it different for the different types of users?
Yeah, so when the initial rollout happened, it was a major sort of rollout. We had live training sessions. We have sort of webinars and sort of videos that we recorded. We did hackathons and all these sorts of local on-the-ground efforts. That's not fully sustainable over time, right? You can do that every maybe a couple of years or something. It's very expensive, right, to fly people around and bring them out of their job. So really thinking about the virtual community and how do we get people to think about a digital workspace, leveraging some of the the newer technologies. So that's really the piece, just like Mark was saying about the community and energy. How do you actually take that and have it in your organization, like the energy of the Tableau conference and the folks around there. If you can bring back, one of the greatest things I thought about the Tableau community was I was working in sort of these offices, trying to talk about data, and everyone's like, who are you? And then I realized, like, come to a place where there's 15,000 like data geeks and nerds, and you're like, wow, this is pretty cool. And you bring that energy back. So we're trying to sort of do that back home.
I think Tableau does a good job of that too, Brad, making a lot of these available on video on demand so they can experience some of the energy even if they're not here.
Yep.
So that's the onboarding piece. So what did you learn? And so if someone was starting this initiative today, what are the tips that you'd give them? And maybe what was the best decision that you made in terms of getting started?
Yeah, so the best decision is more about the strategy of democratization and having folks from different backgrounds. And so sticking by the guns on that in terms of if you have coders or non-coders, a solution might have the best in breed, sort of, but then you'll have, you're excluding people. So having a very inclusive environment where, you might not have the whiz-bang technology right away, but the organization's not ready for that anyway. It's an experimentation. So really sticking to your guns, if you say it in a way, of saying, all right, we're going to empower everyone. It's not an easy thing to say when you're trying to solve business problems every day and everyone's like, well, I have this thing, I'm trying to do this, I need that. It's like, slow down, all right? Everyone, like TensorFlow, no, not everyone needs to do deep learning at scale in the corporation. Like, we need to solve basic problems, right? And so being able to stick by that was a big piece. I think, if you look at the lessons learned and what we're starting to evolve to is thinking of our internal data platform as an actual product. And people say that all the time, but I think, you talk about product owners and product managers, but then really thinking about overall hierarchy strategy. So one simple one that we used for a while was, people want to find, explore, understand, share, or activate analytics. And so in those themes, what are the different innovative features and capabilities that we're trying to solve for? And then maintaining it, really like a CRM, like really in a product management database, having features tied to user stories. And over time, you'll see that the user stories remain pretty much the same, all right? The features, pretty much the same, actually, if you go back 5-6 years. It's more about how's they're actually done at a task level. And, companies are innovating across the board, and if I go back, my team comes to me all the time with some great ideas. We can look it up in the idea database, see what the evolution was and the evaluation. So really being rigorous about this is a lot. It's overhead, but you'll see that over time, you'll get the same questions, and to be able to address them in the same way is interesting. And really, when we rolled this out, we were thinking more about the external stakeholders. You're really communicating the broad vision and goal. I think that was a great idea. However, we didn't really focus internally. Like, what does that mean for our developers? And as we start to look at people building new parts of the platform, people supporting parts of the platform, and people using part of the platform, like, what is that roadmap? What is the, like I say, user stories to this? Because when you have the support team at scale now, we have an entire team dedicated to supporting this platform. They may not know the original idea of why we developed certain features. And so for them to be able to go in, understand what was the persona we were thinking about, to be able to give that same user experience over time is very challenging, but something I would have liked to set up much earlier.
So you have some unique challenges, given global usage, given the industry you're in, highly regulated. How do you apply governance to all this so that you're not just scaling the chaos as you scale your data science capabilities?
Yeah, the governance is it's a famous word. It's used across. But what does that actually mean? Different types of governance. From a data science perspective, thinking about, like, everyone wants to spin up their own cluster. I can do 1,000 Jupyter notebooks. I can run auto ML, but then if you start looking at the cloud computation costs, you're like, hold on, it may not be such a great idea. Let's maybe just do a bar chart instead of spending $15,000 optimizing something. So how do you actually govern sort of the compute and sort of what people are doing? That's one. It's a big area. I mean, there's data governance, there's techniques. So what we're trying to do is just give best practices, have an internal marketplace where people can go in and look at previous projects. So we're developing templates of workflows that people can go in. I'm trying to do a churn analysis. Here's a templatized workflow that's already been sort of helped out for folks to build certain reusable components in there. And so we can govern it that way. I think if you look at sort of how the tracking and monitoring of the different applications, we're able to understand who's using what data sets, who's using what apps or plugins or recipes, and then start targeting that, and then actually working with vendors to build those into their product. And so that way we don't have to actually support those sort of custom extensions. And so we've had a lot of great success in that. And it will help you actually communicate with your vendors. If you have your roadmap and your sort of ability to say, here, this is used 10,000 times, guys, why don't you build this into your product, And so having that communication and ongoing partnership with vendors that are providing software is critical as well.
So I know I've asked you a lot of questions. I want to give the audience a chance to ask questions. So we have a microphone. So if any of you all have questions for Chris or for me, please raise your hand and Divya will bring the mic to you. While we're doing that, how do people find out about the system internally? Do you do internal marketing to make them aware that this is available to them?
Yeah, we used to do something, Data Science Thursdays, and it would be a lot of it is actually modeled after the Tableau. So having clinics, those types of things that were asked, the data doctor and things like that. Like we started to do that, fun things if you look at about 4 or 5 years ago when those articles came out, everyone thought the data scientist was some unicorn and they're afraid to ask questions. So it was like, stump the data scientist, come in with, make it fun, come in to our studio and solve a problem in real time. So things like the Viz Wars, do it at data science, just come in, let's try to solve a problem together and make it much more accessible. And that's actually when we started to hit a big turning point, was when we made it more accessible and not so scary.
Question?
Yep, thank you. I work with insurance and banking clients that talk about the same type of problem when it comes to getting into AI, ML models, training and reusing them. And the theme is collaboration and reuse. The theme is there a way for us to do with a platform like this or otherwise, parts of the logic that we can take out as modular pieces and reuse? So we don't want to figure out the entire end-to-end, an actuary's job for risk or an index or profitability or likelihood to fail. We want to pick up part 1 and part 7, and we want to make those always reusable, and we can build different flows with them. So the idea of a library of components of the model that are reusable, is that something you do at Pfizer? Is that something that the tool allows, where you can kind of take pieces of the logic and build new logic with it?
Definitely. So that's exactly how we're trying to scale the data science part. But it's you can think of it in the entire workflow. So from a simple file utility, let's say we're accessing publicly available data, and it's requires someone to FTP or SFFT or something, hit an S3 bucket, extract information, hit an API. We can actually encapsulate that, provide that as a plugin so people can connect to that. So those are things on the data engineering piece we can encapsulate. You can do it on the algorithm side. So if there's a new algorithm, a month ago, Stanford, some folks came out with a pretty cool sort of the next version of XG Boost. We can actually take the open source, plug it into Dataiku, actually enable everyone to start playing with it once we've determined it's usable. It's not just a fad that's going to go overnight and change. So we're able to modularize that. So there's the concept of this marketplace. So there's a place where you can go in, plugins, all kinds of plugins, enrichment plugins. So that's exactly what we're doing. I mean, I think the challenge is how do you maintain that, and that's probably where we're trying to figure out exactly the publishing rights of an internal app store, right? So like, you can publish anything, right? And then 3 months later, if no one's supporting it, it becomes a problem. So, but definitely, that's exactly where you take components of the flow. And then what you can actually do is start analyzing existing projects. So don't go out there with a pre-mindset of, I'm going to build these libraries. You know, go and look at what the top flows are, what the top components are, and then build those subcomponents.
You can link flows as well, and plugins are definitely something that's Pfizer uses quite a bit, and because it does allow to automate a lot of what the data scientist does for everybody.
Switch one with a part of another or something like that.
Yeah, and you can do that not only with flows but with code. So if you have like a stub or sort of like a functional script that you can just replace variables in like Python or SQL or anything, you can encapsulate that. People can search, how do I best transform a pivot, wide to long or whatever. And then it could be, here are the templates that the data science team uses.
Any other questions out there? Gonna make it easy on us. Well, with that, we thank you all for your time. Chris, thank you for joining us up here.
Thanks.
Have a great